So we kicked off the last topic the last day, which is consciousness. And we noted that it's a difficult topic. Consciousness is not a single thing that one could describe, for example, in 2 sentences. It's even difficult to know what are the right questions to ask. Should we ask, does the brain make consciousness? Should we ask, does it arise in the brain? Is it related to the brain? Maybe brains have nothing to do with it, and so on. And the only observation we really got to the last day was this, that when people use the word consciousness, they tend to mean a bunch of different things. So it's slightly odd to treat consciousness as if it was a substance. That's Descartes might have gone along with that, but we don't really go along with that. And when considering consciousness, you always have to check the facts of your own experience here. And so mainly what we're doing in this lecture is sorting out the different things that people mean when they talk about consciousness. And we introduced the first distinction the last day between access consciousness and phenomenal consciousness. We'll tease this apart now today. Access consciousness refers roughly to the set of things you can report on at any given moment. Those things that you're sufficiently aware of that you can say, yes, it hurts, I feel it, I see it. Those things. Phenomenal consciousness may seem to mean the same thing. It's everything that's present to you at any given instant. But access consciousness, for example, contrasts nicely with the unconscious. Phenomenal consciousness doesn't. And we'll tease both of these apart a little more now, starting with access consciousness. It's much easier. Access consciousness is nicely illustrated by the tip of the tongue phenomenon. You're all familiar with this. You're searching for a word and you know it, and it's not quite there. It's not yet. You don't have access to it. And you're going, yeah, it's got 3 syllables. It begins with a B. It's murmur. Right? And you get it wrong. And that's what happens to me. So the tip of the tongue state, there you go, illustrates this notion of access consciousness very, very nicely. If you can't quite reach it, you don't have access to it, right? And this, you could say that, well, he knows the word, he knows the answer, so it's there, but it lies in his unconscious. And when we do this, we're tapping into a vocabulary that comes from outside science. It comes from the contribution of Sigmund Freud. Freud was part of the story of the early days of psychology, and he founded the discipline of psychoanalysis, and he confidently expected his groundbreaking work to lead directly to science. But it never really did. Psychoanalysis has a weird history, went on to develop, and there's many, many variants on it. And the vocabulary of this that gives us the notion of the subconscious or the unconscious has gone into our everyday language. It informs the way we think about ourselves, but it hasn't really made its way into the scientific domain. It's a very influential way of thinking about things. So we're using this notion, which relies to some extent on pre-theoretical assumptions or ways of talking about our experience. So access consciousness just kind of refers to the set of things you can provide verbal report on. And there's an assumption here, which is that you can report on things that form part of your experience. That might not be accurate. Make up your own mind on that. I don't know. And like almost everything around the domain of consciousness, we have to be careful. When you see a term used like access consciousness, check that they're using it the right way. So I see there is a kind of a new agey appropriation of the term access consciousness to mean something like enlightenment on the cheap. We won't have anything to do with that in this module. So check the authority of the people when you meet discussion around consciousness. There's a lot of woo there as well. Now, access consciousness as a notion is sufficiently well defined that we can begin to do some science of it. And we're going to meet something called global workspace theory, which is the name given to an experimental agenda, including some very good behavioral and neuroscience, perfectly respectable science, but it's in an area there where we have to be very cautious about what it is that we're saying. We have to be very clear about what it is that we're saying. And when we approach access consciousness here in the sense that it's used within global workspace theory, we're self-consciously employing a metaphor. a metaphor for thinking about our own experience, our own lived experience. It's up to you whether you like this metaphor or not. Okay, it's of some use perhaps. There's some things it gets, some things it doesn't get. But it's a simple metaphor, and it's the metaphor of a spotlight in a theater. So if you can imagine the set of things you are potentially aware of as being like the theater, then the stuff that you're paying attention to is like that which is captured in the spotlight itself. And the spotlight is on a stage, so there's a load of stuff nearby vying for attention, but the spotlight has only limited capacity, and it can move from one to the other. And there's a whole bunch of other potential stuff that's maybe not so nearly available. So we can distinguish between the contents of the stage and perhaps the backstage or the audience. It's a loose metaphor, but I hope you can see that it's one way of thinking in this domain that helps us to be precise in our articulation. Here it is worked out a little bit further. So the spotlight is like sometimes called the spotlight of attention. And we see attention is one of those concepts that is strongly mixed up with our discussion of consciousness. And you can imagine the sensory inputs competing for access to that. So as your attention turns from what am I listening to, what am I seeing, what am I feeling, what am I remembering, you can see that as the spotlight wandering around, being pulled here and there. And there's a bunch of stuff that's fairly easy to get at. Let's say the contents of working memory, called the stage here. And the other parts are in like long-term memory or your remote memories. You can imagine that as being the backstage or the audience. We don't have to take it too literally, but this metaphor is a useful way of laying out what it is we're talking about and distinguishing it from all those other uses of the term consciousness that don't warrant being spelled out in accordance with this metaphor. So global workspace theory is a scientific theory developed based on something like this metaphor. It uses the language of information processing, which is one orthodoxy within neuroscience. And the idea is that, for example, when you recognize a word, that is the end product of a series of stages in which we start with visual information and we end up knowing what the word means. And as this process unfolds, the early stages are not available to consciousness. That's where the word is becoming recognized. And then there comes a point at which you recognize the word, its meaning is now available. And at that point, presumably, because the meaning is available, there's a rich set of associations around the word. So hamster, okay, you heard the word hamster and suddenly you're thinking about furry animals and wheels and deserts and gerbils and sawdust and childhood and all those associations that become available once you have the meaning of the word. And in global workspace theory, what we do is we try and follow these stages on the assumption that the early stages are concerned mainly with figuring out low-level properties of the visual input. And the later stages have more to do with this larger sense of meaning and association, which should presumably show up as massively distributed activation over the whole brain. I'll show you what this means in the context of a specific experiment done by Stan DeHaan, in which words are presented to people. So their subjects in this experiment are sitting down in front of a screen, and you're going to show them a bunch of very carefully timed, calibrated screens, and occasionally there's going to be a very brief presentation of a word. So brief that you don't know, did I see that? Did I see that? I don't know. And there's stuff coming on. And what we'll do is we'll have a contrast between two conditions. Here's some examples. Over there on the left, you can see a succession of screens. Some of them have this masking pattern on it. So that's there to provide you with some visual input that's not word-like. And then a word crops up, lion. And then that's only shown for 29 milliseconds. That's really, really brief. But then there's a blank screen afterwards for another 71 milliseconds, making 100 milliseconds in which you're either seeing the word or nothing. And then there's more of that visual masking. And in the other condition, we likewise have a succession of masks and blank screens, but when the word appears here, it's followed by a mask, right? Now, maybe you're familiar with this idea. If you go into a room in the dark and you flick the switch on and off really, really quickly, then even after it gets dark, you have a sort of a retinal after image that you can still query, you can still, as if you were looking at things. Well, over there on the left-hand side, where lion is presented very briefly, You then have a blank screen so that if there's a retinal after image, you have more time to sort of process what you just saw. Whereas over here, when the word is presented, it's immediately followed by a mask so that there's more visual information coming in, so you don't have that option. And these times are carefully chosen so that on the left-hand side, subjects are quite likely to say lion. And on the right-hand side, they're quite likely to say, I don't know. Right? So it's just, they don't know. And we've seen some of the techniques you can use to study what's going on. So on the one hand, we have the behavioral response, lion versus I don't know. But we can do this, for example, in a scanner, in a brain scanner, using functional magnetic resonance imaging. And we can look for those areas in the brain which receive increased blood flow in one case and in the other case, and we can compare them. And here's the kind of images we get there. On the right-hand side, you see this, you see a few localized areas which are presumably involved in trying to decode the very, very brief pattern of light and dark on the screen. But this is the condition where the subjects don't know the word. And you can contrast that with the left-hand side where you can see much more distributed activity, very many areas of the brain. This is the point at which the meaning of the word becomes available, the point at which that meaning then begins itself to form associations, and so we get an awful lot going on. Now this is consistent with global work. It doesn't prove, we don't prove things. It's consistent with global workspace theory, and you can imagine on the right-hand side we've presented the word, but it didn't make it into the spotlight. It didn't reach access consciousness. Over on the left-hand side, it made it into the spotlight. The meaning of the word becomes apparent, and that causes this massive increase in distributed activity around the brain. So this is a scientific theory. Because of the way we've laid out this notion of access consciousness, we can compare these two conditions meaningfully. We've got a behavioral distinction. On the one hand, subjects can report the word. On the other one, they can't. We have this distinction in fMRI. So that's nice. And it would be nice if we had further converging evidence. So there's the fMRI data, but there in the middle you can see additional data obtained using EEG. That's reading the electrical activity on the scalp, specifically using the method of evoked response potentials. This requires a lot of repeated presentation of the stimulus. But what you can see there is the green response is an electrical signal associated with those cases where you can report on the word, where it makes it into access consciousness. And the red one is the average response for those cases where you don't report on the word. So the EEG data is telling us something similar to the fMRI data, which is telling us something similar to the behavioral data, all of which is adding up to quite a nice, rounded scientific story. Despite the difficulties in the area, then we're seeing evidence that there's something going on prior to recognition, but that with recognition, something fundamentally different changes. Now, this global workspace theory and that view of what the brain is doing all lies within one particular framework. I called it there the Cognitivist Framework or the Information Processing Framework. It's very much an orthodoxy in cognitive neuroscience. But I hope we've made it clear throughout this module that there are many frameworks available within cognitive science, and there's no single overarching orthodoxy. That's one of the reasons it's both exciting and challenging at the same time. So there are some questions we can ask, meaningful questions we can ask about ourselves and our behavior and our experience that can be addressed within that framework, but there are probably some questions that cannot and for which we would need a different framework. And we've seen the difficulty of choosing the right framework and what happens when you use the wrong framework. We've seen that throughout this course. But while we're on the topic of access consciousness, there's a weird little historical story that's worth telling, which you've probably cottoned into. And this is the notion of subliminal advertising. I'm sure you're all familiar with the idea that you're sitting there on the screen and the message briefly pops up like this. Hungry? Eat popcorn. But it pops up so quickly you didn't see it, just like that one condition in Stan DeHane's experiment. But you're sitting there watching the movie going, I'm kind of hungry. I feel like eating some popcorn right now. You've all heard of subliminal advertising, right? Does it work? Ha! Ha! Here's the story. 1957, this chancellor called James Vickeray held a press conference in Chicago. He said he developed a powerful new technique to influence consumers. That gets attention. It was marketers and journalists and so on who were at the press conference. And that hungry, eat popcorn was one of the images he showed. Drink Coca-Cola, those kinds of things. Cinema was now a mass art. People were flocking to the cinema. And if you could sell stuff to them effectively, that would be of interest to certain people. He claimed it was amazingly effective, and people bought into it. It was such a nice idea. Weird and spooky, you're being influenced beyond your control, but kind of nice and sciencey and future technologies, science fiction-y from the point of view of 1957. However, none of this was built on science. He hadn't done any science. There were no experiments. There's no science in the journals about this. And 5 years later, he admitted he just made it all up. Okay. Unfortunately, the idea caught on and people really, really believed it. Now, Stan Dehaene's experiments tells you that if you don't get to the stage where you recognize the word, it's kind of lost. You don't get the set of associations. You wouldn't get to go, oh yeah, I'm feeling hungry, unless you had actually consciously recognized the word. So we can do science in this area, and the claims of subliminal advertising have been thoroughly debunked. It doesn't work. That does not mean that your behavior cannot be subtly manipulated and influenced from the outside. It gets rid of the idea that briefly flashing up words can convey the meaning of those words, which can then unconsciously influence your behavior. But the layout of our modern supermarkets and Tesco and so on are testaments to the gentle, subtle nudges that subtle visual cues, layout, colors, smells, and so on, they do influence your behavior, and they are manipulated, and you are steered by them. But this specific claim that words flashed up briefly will influence your behavior has had a very powerful hold on the imagination. And to this day, you'll find things like a subliminal company trying to tell you they can teach you things or make you lose weight and seduce others and get rich quick and be highly effective in your life through these kind of techniques. The idea that there's hidden messages in rock music, for example, satanic messages in Led Zeppelin. Swear it's there, just play it backwards. Right? Neurolinguistic programming we've called out before. The idea that you can be brainwashed by these hidden messages is bumf. Okay? There's a point to, these kind of subtle resonances that maybe influence our thinking when we see something, they're real up to a point. But the original claims of subliminal advertising are not. And it's good science in the domain of access consciousness that showed us this. So what about this other one? Phenomenal consciousness. And here we have to get into the topic of your required reading for this week, which is a Scientific American article by a chap called Dave Chalmers. 20 years ago, there was not really a science of consciousness. And it took a philosopher, this guy, Dave Chalmers, to organize our questions sufficiently so that people felt safe as scientists approaching this definition of consciousness or that definition of consciousness, knowing they weren't solving all the problems, but knowing that we were now in a position to do some science in this area without making fools of ourselves. And so the good work that Dave did was sorting out these questions, and he grouped them into two big groups. He said, here's a bunch of easy questions, and here's a hard question. When he says easy and hard, he doesn't really mean easy and hard. The easy questions are anything but easy. They're very, very difficult, and each of the easy questions is a topic of ongoing scientific work that's challenging. But what he means by easy is that you can consider doing science as we know it, as we've got used to the practice of science. You can do science to address these kinds of questions. So that little experiment we just saw by Stan Dehaene, that's science as usual, addressing a question within the field of access consciousness, using a limited definition of access consciousness. And that's an example of what Chalmers would call an easy question. Not because it's easy, but because we can do science as we currently understand science in the area. The kind of science we have is suited to inquiring into this kind of question. That's what he means by an easy question. There's a whole bunch of other easy questions around a very different sense of the word consciousness that we haven't even mentioned yet. Forget access consciousness and phenomenal consciousness. What about states of consciousness? There's something that we want to talk about when we make a difference between someone who's asleep and someone who's awake. Someone who's in a coma, someone who's out of their head on drugs, someone who's been hypnotized, someone who's dreaming and not dreaming. We also use the word consciousness here, and that's a very, very, very different sense. So states of consciousness need to be indexed. We need to be able to distinguish between them, and we need to be able to, for example, recognize the neural signatures of coma and distinguish it from deep sleep. That's very, very important for a medical point of view. It's not philosophically challenged. There are interesting philosophical questions associated with it, but this is fairly straightforward. We know what we mean when we say someone is asleep. What does that look like in the brain? Yes, we can do science there. So that's a very useful sense of the word consciousness, is to distinguish between these global kinds of states. Are you on drugs? Are you psychotic? Are you asleep? Are you hypnotized? So as you can see, this is an entirely different sense of the word consciousness. There's another bunch of easy questions. I shouldn't say number 2, because this is just more easy questions, easy in this limited sense, on something called the neural correlates of consciousness. So as we recognize that there's different states of consciousness, and as we recognize that the content, your conscious awareness involves things like perceiving and remembering, problem solving, imagining, and so on, we can ask, well, when you're seeing something, or when you're remembering something, or when you're out of your head on drugs, what's going on in your brain? That doesn't ask, how did the brain do that? It asks, what's going on in the brain while you're aware of such and such a thing? It's a big difference. Now, there's a chap who's most associated with this here, Christoph Koch, who subscribes to the view that what perception is to take in information and build up mental representations. A view we've met several times here. One possible view. This fits very, very well, but there's other approaches to all the topics we met in cognitive science, and in each case, you can always ask, well, while that's going on, what's going on in the brain at the same time? That's why we mean correlates of consciousness. For an example we met when we were talking about visual perception was the distinction between the where stream and the what stream. The dorsal stream, where we know that the brain activity has something to do with not walking into lampposts, with dealing with the issue of movement, whether it's you moving or things in the world moving. While the ventral stream, the cortical activity, is associated with recognizing things, identifying them, and labeling them. Now, making that kind of distinction is to ask about neural correlates of consciousness. What's going on? I'm walking, I'm navigating, I'm trying to avoid things. And we see there's this going on in the brain. It doesn't mean that part of the brain is doing it, but it's a correlational exercise. That's what's going on in the brain, in this part of the brain, while this is happening. What's going on in the brain while you're recognizing, labeling the names of celebrities, for example. Now, there's questions that arise when we do this, and they're not, contrary to David Chalmers, they're not easy, they're very hard questions. One of these questions is, hang on, if there's two different areas in the brain, or two different pathways in the brain that seem to be performing two different functions, how is it that I only have one sense of visual experience? I don't have a sense of movement processing and versus identification, I just see. Well, that's a good, juicy problem known as the binding problem, but it's the kind of question we can ask and hopefully address within the scientific framework that we currently have. So, for example, we might find synchronization between distant areas in the brain so that they are locked together in time, which would help to remove that problem. I don't know, it doesn't matter, we don't have to know the answer. All these belong in the set of questions that we can address using science as we understand science. Now we come to this notion of phenomenal consciousness. And this is what Chalmers calls the hard question. And this is, why does anything feel like anything at all? Why is there a subjective experience, first person, subjective lived experience? And this is a hard question. It's, on one hand, it's the most obvious, easy, straightforward thing in the world. How could you not understand what I'm saying? You're sitting there viewing the world in the first person, singular, having your own experience that's distinct from everyone else's. But our language really trips us up here. And as you'll see, the best way to articulate this question is with a variety of sort of thought experiments. But one word that Chalmers introduces that philosophers find useful, I can't stand it myself, is qualia. This is useful for discussing the subjective element to experience. What is it like to see red? So, for example, I know what it's like for me to see red. I don't know what it's like for you to see red. I can verify using language that anytime I say, yeah, that looks red, you would also say, yeah, that looks red. We might even disagree there. But supposing we can agree there, I still can't be sure that red looks to you as it looks to me. I can just verify that you're using the same word. And if redness doesn't do it for you, and it is an example that's trotted out shamefully often, a more convincing one is pain. You know the old, this hurts me more than it hurts you? No, it doesn't, right? If you bang your thumb with a hammer and someone says, I feel for you, you tell them to get the hell out of here, it's my pain, right? That sense in which you're experiencing the pain. It's the most obvious thing in the world, very difficult to communicate. That's the notion of qualia. It's this incommunicable for me-ness of experience. Ineffable, meaning you can't actually put it into words. You can use words to align and coordinate, but you can't communicate it directly in this way. It's private. Now, what the hell use is this concept? Well, imagine, if you will, that you encounter a replicant. Does anybody know what a replicant is? From Blade Runner. If you haven't seen Blade Runner, once more your homework is to go watch a good film. Watch Blade Runner. It's a brilliant film. In Blade Runner, they have replicants. Replicants walk and talk like human beings. They are in every respect indistinguishable from human beings. However, they're just robots. They're no more sentient than a toaster. We know that because we made them in our super robot factories. And so it's quite okay to switch them off when they've served their function. Put it another way, can you imagine something that walks and talks and seems in every way to be like a human being, but there's no light on inside? Well, this concept is sufficiently interesting. It's got a name introduced by Dave Chalmers again. We call them zombies, not the Hollywood zombie. The philosophical zombie is indistinguishable from you on any measurable criterion, but by hypothesis, there's no light on inside. There's no actual awareness. Does that make sense? Or would you be forced to say, if it walks and talks like a human, that it has experience? I don't have answers. You don't have answers. It's a good question. This notion of the philosophical zombie, it's a useful way of addressing in language that which language seems to have difficulty in expressing. There's another way of doing this. Imagine Mary here. Mary is a bright woman who was brought up in an entirely black and white environment. Maybe it's something to do with her visual system, or maybe it's her evil parents, I don't know, but she's been in a black and white environment all her life. But she's gone to university, she's trained, and she's learned everything we know about color. She's read all the textbooks on color. She's done the experiments, she can draw the graphs, she knows about the visual processing, anything that anyone has written that we know about color, she's read. Now one day, either her sight is restored or she walks into a colored-y environment. What does she now know that she didn't know before? Because by hypothesis, it's not something you can write down. What did she learn by experiencing color as opposed to knowing about color? That's the intrinsically subjective element of consciousness that's so difficult to put into words. And as I'm talking about this, you'll notice that there's a couple of terms that sort of keep intruding. If I try to describe this ineffable domain of phenomenal consciousness, or even with access consciousness, I end up using words like awareness and attention an awful lot. And consciousness, awareness, and attention all vie for position, and they're wielded in ways that are mutually sometimes compatible, sometimes not compatible. Psychologists tend to like words awareness and attention because they think they tend not to get them into philosophical difficulties. We might question that, but the notion of awareness and attention are useful notions that skirt around questions of consciousness. Here's an example of an interesting one which we find sometimes in people who've had a stroke on one side. So if you have a stroke on one side, you may find unilateral neglect. These are people who can see the entire visual field, but they can only attend to one half of it. Now we know they can see the entire visual field because we do all these tests. Look straight ahead. How many fingers? I don't know. No guess. 3. How many fingers? I don't know. No guess. 2. And you can shine lights, and they can see, but they can't report on it. These are examples of drawings done by patients who have unilateral neglect from models, and you can see that half of the picture is sort of ignored. This follows damage to one side of the brain, and although we can demonstrate that they can see, they can't attend. It's a kind of a dissociation between seeing and attending, which is very interesting. These people will put on makeup, and they'll only put on makeup on one half of their face, and they won't notice that that looks totally incongruous. You put a dinner in front of them, you come back later, half the dinner is eaten, you say, oh, you weren't hungry, and they go, no, I ran out of food. You turn the dish around, and they carry on eating. Even though they can see on that side, they can't pay attention to it. Bizarre set of phenomena illustrating that these are not only problems that philosophers have. Finding the right language to discuss concepts like awareness and attention and consciousness is necessary for medical purposes. It's necessary in order to do justice to the rich and sometimes challenging experiences that people have in illness. Another area in which we see something similar to the notion of access consciousness is in a distinction that psychologists like to make between controlled processes and automatic processes. Now, I want you to put yourself into the shoes of a mediocre pianist who's learning a new phrase on the piano for the first time. And it's written there, and it's kind of difficult, it's challenging. There's a bunch of notes, and they've got different, it's maybe in a different time, different rhythm, or difficult rhythm, and so you have to pick it out note for note. You have to go sort of B flat, G, do that, boing, 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 boing. You have to play each note after the other. That's very much a controlled process. And if you practice that for a long time, let's just assume you're very good at the piano and you practice it, and it just kind of becomes automatic, so you don't have to think about it. And when it's automatic, it's fluent, and you're not even aware of it. You're not aware of it in the same way. And there seems to be a strong distinction between the kind of task that requires your conscious awareness. You have to pay attention to it. You couldn't be talking on the phone and doing it, whereas later on, when it becomes automatic, you could. It's slow, it consumes your resources. But once it becomes automatic, it takes little or no effort. You don't seem to be aware of it in the same way. It doesn't require a lot of attention, and you can do other things at the same time. Now, very many of the skills we acquire in life go through this process, where they're first of all clunky and then smooth and fluent. If any of you learn to juggle, first you like this, and then after a while it's just like this. And if you haven't gone through that with juggling, I assure you you've gone through it with reading. There was a time when reading was hard. It's hard to remember a time when reading was hard. But there was a time when you were faced with a word and you go, I don't know. Right? So reading is an example of a task that started off effortful, consuming resources, slow, clunky, and very much occupying your attention, and then it becomes automatic through a process of automatization. So there's a lot of tests you can do to follow this passage. One of the most famous ones is known as the Stroop effect, which you're all going to illustrate right now. I'm going to show you a list of words. I want you to read them from right to left. They're the names of colors. Just read them out loud from right to left and go. I was just checking you'd all learn to read. You're very good. You pass. Okay, now we're going to do it again. Now read them from left to right, but this time don't read the word. Just name the color, the ink.
Blue, red, yellow, green.
The answer was blue, red, yellow, green. Try it again.
Blue, red, yellow, red.
I think you can see it makes a big difference, right? You can't not read after a while. Not only is it easy, it's obligatory. So this is a very well-known effect known as the Stroop effect, and it's available in about 1 million different flavors and varieties to test all kinds of interesting things. I think reading here is the tip of the iceberg. Most of the way that we engage with the world is fluent and not particularly conscious. But as you can see, our language is a problem here. We're still in the business of developing the right concepts to tease apart these issues, to look at the many aspects of our experienced lives, our lived lives, some of which are amenable to scientific investigation, maybe some not. So there's a lot of people interested in the area of consciousness, as well as cognitive scientists and neuroscientists. Psychologists are interested, and psychology comes in all flavors, from very scientific to not at all scientific, but they're all interested in this area. Psychiatrists are desperately grasping for the necessary concepts to deal with human suffering, which is, of course, an experienced thing. There's a whole branch of philosophy known as phenomenology, which just tries to analyze experience without reference to science, more or less. We met Freud and his somewhat bizarre set of theories as to how experience comes into being. It's not part of science, but it's interesting. There's some really interesting work in interfaces between science and the contemplative traditions of the East. And by that I mean the philosophical traditions underlying the Vedantic tradition, which you might think of as Hinduism, but it's a specific school of philosophy in India, Taoism, and Buddhist epistemology. These are philosophical traditions that have taken the study of consciousness very, very seriously. So there's a lot of interesting exchanges going on there at the moment. Some of the best work in this area, frankly, is done by poets and authors, novelists, and so on, in describing what it feels like to be a person. If you read Dostoevsky, you know what it's like to kill an old woman with an axe. Right? Until you read Crime and Punishment, you hope you don't know that. Physicists are notably absent here. Physics used to care that its theories made contact with everyday experience. It's very hard to bridge that gap now, but there's still a need to ensure that, well, whatever we're doing in the science in this area is continuous with science in other areas. And here we come sort of to the last big concept in this course. If you think science is simply in the business of delivering objective accounts, objective facts, that rules out any science of consciousness, because as we've seen, and as Chalmers articulates, the hard problem of consciousness is necessarily, it belongs to a subject. There's a subject who sees the world in first person. Now, a lot of scientists, and most non-scientists, subscribe to the belief that what science is simply providing an objective account. That turns out to be a very problematic concept itself. And one of the obvious reasons it's problematic is that if you rule out any appeal to what it feels like to experience, you've ruled out any hope of science addressing questions like suffering, meaning, value, feelings, and so on. And these are things that we need science to help us make progress in. So I'm not going to give you a simple answer here. I'm going to point out that as we explore the business and learn how to do science in areas that science has not normally gone, then science gets a little bit bigger and we get a little bit richer as a result. Areas there's lots of areas in cognitive science we have not had a chance to approach. There's some very interesting work at the moment in cognitive science that sees what we've hitherto associated with brains, sees not as anything to do with brains at all, but as something to do with the processes of life. So there are strongly biological approaches to the topics of cognitive science that are leaving psychological approaches to one side somewhat, and understanding mind as a condition of life. I'm just going to include for your reference, in case you want to chase it up, a whole bunch of books that come at this from very many angles, from physics, from biology, from philosophy, and from cognitive science. I'm just putting that there because we're back where we started in this course. When we started, I said that we pointed out that drawing a sharp distinction between minds and bodies, or between the mental and the physical, was not going to be possible. Well, in just the same way, we have to pull back from any association of any understanding of the world as sharply divided into subjects and objects, or into subjective accounts and objective accounts, where the objective accounts are real and the subjective accounts are just opinion. That's not going to work. But as we learn to do science in this area, things get a little bit strange. We're going down the rabbit hole. Many of you remember this scene from The Matrix. Because as we learn more about how to do science in this area, we're learning more about what it is ourselves, and our experience might thereby be transformed. Our understanding of who and what we are might thereby be transformed. That's quite different from most kinds of science. And so I'm going to wrap it up here with the point that we ended the first set of topics at. Alchemy at one stage was an interesting business in which there was a great plurality of theories, people playing around, messing with materials, looking for the secret of eternal life, looking to turn lead into gold, looking for all kinds of unreasonable things. It was great fun, but out of all this activity came some good science, such as chemistry, for example, which evolved directly from this. And it was necessary, to have this Wild West stage before you get the discipline stage of chemistry. So you can think of some of the activity in cognitive science as still being at this stage where we're spinning off scientific activity. So we're getting good science of access consciousness, but we're still also have a lot of madness and a lot of stuff that's really, really interesting that we're still trying to find our feet. That's where we started the course at this point, and we're ending the course at this point. I hope it was worth the ride. We do have a master's course in cognitive science if you're interested in pursuing this later on. It's a 12-month taught master's course, and we're done. If you get time, leave feedback. It would be very, very useful. You get this anonymous feedback, we pay attention to it. Okay, we're done. Thank you very much.